Welcome back to the physics lecture series. Today we're doing 3 accelerating body problems. I have this first one for you here. It's a simple pulley problem. You have a suspended weight and you have a weight on a horizontal plane, and it's connected by a string by a pulley, and the hanging mass is pulling on the system. Just off of initial inspection, what do we think will occur here? Well, we think that this 9 kilogram weight, because it's heavier, might, and depending on the surface, because there is a friction constant here of 0.2, we should relatively expect maybe this weight to accelerate the system downwards and pull that block to the left. Okay, so we are asked in this problem to find not only the acceleration, but the tension of the string. So how do you go about solving a problem like this, right? Maybe go ahead and give it a shot if you think that you might be able to do it. But if not, we're going to walk through it and we're going to make sure we understand it. Okay, so the first thing you always do with a complicated kind of problem like this is you draw a free body diagram of any body with forces acting on it. So in this example, the string doesn't have any mass. We're assuming that's negligible, right? This is just a simple physics problem. A and B respectively have their own forces acting on it. Let's draw the free body diagrams for each. So I have block A right here. What are the forces acting on this object? Well, the first one you're going to notice is the force of gravity, right? The force of gravity is equal to the block's mass times acceleration due to gravity, which is 9.81 meters a second. So what does this come out to? 9 times 9.81. This is equal to, and I'll actually put it on this side, 88.3 newtons. So there's 88.3 newtons of force. Because this object is just suspended over space on a string, it wants to go down 88.3 newtons. But there's a counteracting force because it's not really moving that fast. There's a string providing the block tension. What is the force of tension? We don't know. That's something we have to solve for in this problem. We're not given that. So we'll call it F of t for now. Let's look at B here. Well, the main forces we care about is kind of different from the forces that are actually all there. We care about the X forces because we know that there's a force of tension pulling the block to the left, right? Force of tension's pulling this way, but there is another counteracting force. And remember, there's friction. So in the opposite direction, not equal in magnitude, but opposite in direction, the force of friction. Right? So we need to solve for that. The force of friction, the force of tension, it's a tug of war. Who's going to win? Probably the force of tension, right? Because we're assuming if this problem is here, the block should be accelerating. Okay. There are 2 other forces, and this is going to be crucial to help us solve for the force of friction. Do you remember? That's going to be the weight, mass times gravity. And in this case, 5 times 9.81, that's going to be 49.1 newtons. But that's not what's part of the force of friction equation. Remember, we say that the force of friction is equal to the friction constant, and in this case, static, times the normal force. And what is the normal force? Well, that's a contact force, right? If my marker sits on this on my calculator here, it's exerting its mass times acceleration due to gravity. But the calculator is exerting a force upwards called the normal force, and that's equal in magnitude and direction. And it's why things don't just fall right through the ground, right? Because there's an opposite force pushing up on it, right? Quite simple. So we call this the normal force, or 49.1 newtons. Quite simple here. Okie dokie. So let's set up some equations here. We can actually find, if we want, the force of friction. So let's do that. The force of friction, in this case, is going to be equal to the static coefficient constant of 0.2. No units on that. It's just kind of a ratio here. And we're going to do the normal force, 49.1 newtons. 0.2 times 49.1 gives us a force of friction equal to 9.82 newtons. So we'll actually replace the force of friction here with 9.82 newtons. Alrighty, so take a gander at the calculation there that we did. I'm going to erase it for some space. Alrighty, now we have to set up some equations here to find tension. It's going to be a system of equations. Most of these pulley problems, how you solve is by algebraic manipulation. So, where is tension a factor in block A? On the x forces or the y forces? Well, you'd say the y forces, right? So the sum of the forces in the y direction for block A, that's what this means. Sum of forces in the y for block A is equal to mass times gravity minus the force of tension. Right? Let's apply Newton's second law. We want to find acceleration. How are we going to do that? Well, for any system, its overall force is equal to the mass of that body times its acceleration in a due direction. So this is actually all equal to the mass times gravity minus the force of tension. That's equal to the body's mass times its acceleration. We don't know what its acceleration is, but the overall force is going to provide some acceleration, right? So we equal that as such. So now for B, what axis has? Oh, I kind of gave it away. Hopefully you didn't see that. What direction has force of tension as a factor? Well, you'd say that it's the x-axis, right? Force of tension is pushing this way. Static friction is pushing this way. It's a tug of war. So let's call this direction, the force of tension pulling, let's call that positive. And this is force, the sum of the forces for x with respect to mass B. So force of tension's pulling this way. So it's positive. But we're going to subtract the force pushing it this way, which is the 9.82 newtons of friction. And what's that equal to? That's equal to the mass of B times its acceleration. Right? So there's a tug of war. The overall is going to accelerate it one way, and it's probably going to be the force of tension. So now that we have that here, we can solve for one variable. So let's do that. We want to solve for the force of tension, so we could maybe substitute it in here. Right? They both share that term. And let's turn mass times gravity to 49.1 newtons. So to solve here, let's go with x of b, because we can just go it over and we have force of tension. So we say that the force of tension minus the 9.82 newtons is equal to the mass of the body times its acceleration. Let's take over the 9.82 newtons. Force of tension is just equal to the mass of b times its acceleration plus 9.82 newtons, right? It was a subtractive term, but now we're adding it, and that gives us the force of tension. But we don't know the acceleration of the system. We just don't. So how do we figure out acceleration? Well, notice here that we have a term, 49.1 newtons minus the force of tension, and we have some equivalent term of which we know some of these variables, right? So let's plug it in here. Let's plug this into this, right? Kind of makes sense. So I'm kind of running out of room. Let me just make sure that you guys will be able to see. Okay, awesome. So let's bring it down here. 49.1 newtons minus, and let's take mass of B times A plus 9.82 newtons, right? We're going to distribute this negative so we don't get confused. So let's turn this into plus, minus, let's drop the parentheses. So it's 49.1 newtons minus mass of B times A minus 9.82 newtons, right? Just some simple algebra, and it can trip you up. And if it does, I'm sorry, it happens. It happens to the best of us. And then we're also going to have that equal to the mass of A times A. So all we did is we substituted. We said the force of tension is equal to this term here. So it is mathematically possible and equivalent to plug it in for the force of tension there. So now let's rearrange some variables, right? We can combine like terms. We have 2 newtons here. So 49.1 minus 9.82, that gives us 39.3 newtons. Let's add over our mass times B, because we can do a factoring out of something, right? So the 39.3 newtons is equal to ma acceleration plus mb acceleration. What do both of these additive terms have in common? Well, they both have a mass, but they both have the same acceleration, right? Because if this body is accelerating downwards at a certain magnitude, it's also going to be accelerating this body at a certain magnitude at the equal magnitude. So what can we do here? We can factor out the acceleration. That's an important thing to see. So mass of A times mass of B, right, multiplied externally by A. So look at this here. If I were to multiply this back in by distribution, right, it's not just going to one, it's going to both by this relationship that we've set up. It gives us exactly what we had up here. That's equivalent. Hopefully that makes sense there. So what we can do is, since this is a multiplied term, we can divide mass A plus mass B over to give us 39.3 newtons over the mass of the system, or mass of A plus mass of B, is equal to the acceleration. So now we found our first thing that we wanted to find, acceleration. What is that equal to? 39.3 divided by the mass of the system, 9 kilograms plus 5 kilograms. That's 14 kilograms. We get the acceleration of the system is equal to 2.81 meters a second. Ain't that something? So we found the acceleration here, 2.81 meters a second. Look at the math. Let it sink in. I'm going to erase it here. But we know the acceleration of the system is equal to 2.81 meters a second. So we found that. Now, let's find tension. How can we find tension? Take one of your formulas. In fact, we could take this one here. We could solve for force of tension just like this. So notice how we have our equation here that the force of tension is equal to mass B acceleration. We know the acceleration now. We know all the variables to solve for tension. So let's go ahead and do it. Mass of B, 5 kilograms, times acceleration, 2.81 meters a second. That gives us a force of 14.05 newtons. And we're going to simplify it to 3 sig figs. 14.1 newtons plus the 9.82 newtons is equal to the force of tension. What is that? 9.82. Okay. Force of tension is equal to 23.9 newtons. That's the force of tension. That's the acceleration. And the forces of tension are equal, right? Because the string is a system. Hopefully that makes sense. We found acceleration. We found tension. That's how you find these variables. You need to do algebraic manipulation. I have 2 more problems for you. One, they can get a little tricky, but we're gonna work through it, and we're gonna conquer this physics. So to the next problem we go. Okay, so in this problem here, we have block A. Let's assume we have a string and we're pulling. We're pulling with some force this way. And we are asked to find a mathematical relationship for the force of tension. And so we want to get a mathematical relationship for the force of tension, force of acceleration, and the overall force. So how can we do this? Again, let's set up a free body diagram. We're not given numbers here. It's all going to be variables. Variable manipulation. So let's see what we have here. So, and assume that there's no friction is another important note. So we have body A here. There's a force going this way, right? The pulling force, and then the force of tension on that string is pulling back on the thing, right? And that's caused by this block B pulling by tension. So that's the force of tension. B here has a similar kind of thing. But instead of the forward force being just the force, it's the force of tension, right? Because there's a string here, force of tension. Makes sense, right? So that's the free body diagram here. We're asked to make a mathematical relationship for the force, for the force of, force of tension, and then acceleration of the system. So let's set up some mathematical relationships like we did in the last part here. And I think the hardest part for most of you is going to be these free body diagrams, setting up what are the forces acting on the body. Okay, so let's say the sum of the forces, and this is more 1D, so we shouldn't worry about any X or Y forces, right? Of course, there's going to be a weight because these weigh something and it's on Earth, right? But for simplicity, let's just call it force in the X for A, right? So the sum of the forces on X of A is equal to the force of the forwards force minus the force of tension, right? We kind of said that in the last problem, right? There's a force pulling this way, there's a force pulling that way. It's some sort of equilibrium, and that's all going to be equal to the mass of the object times its acceleration. Makes sense? Right? The overall system mass times acceleration, that overall force, right, given by Newton's second law is equal to those two forces subtracted by each other. Alrighty, so force of Y, or sorry, not force of Y, force of X for B on this case is force of tension is equal to mass of B times A. There's only one force. It's the force of tension. There's no force saying, I'm going back, I'm going back, I'm going back. It's only the force of tension pulling it forward, right? Makes sense. Now, if there was friction, and in real life there would be, you'd have a friction force, but not in this problem. We're ignoring friction. So this one's a little bit easier, but we have to solve for some variables. First, the force of tension, and acceleration. Let's solve for acceleration first. That might be the easiest. So we know the force of tension is equal to mass of B times A. We can plug that in here. So we get that the force minus mass of B times A is equal to mass of A, acceleration. Added over, we get mass of A, acceleration, plus mass of B, acceleration, right? And then we can take the overall force is equal to, and remember we factored out the mass of A plus mass of B times acceleration, right? Remember that distributive relationship that we can do. To find acceleration, we have to divide, right? This is a multiplicative term. We want to bring it to the other side. We got to divide it. So the force is equal to mass of A plus mass of B. You could also rewrite this mass of total system if you wanted, right? Taking in both masses. So that's a mathematical relationship for acceleration. Acceleration, so we'll say acceleration is equal to force over mass of A plus mass of B, right? Hopefully that makes sense. All right, I'm going to erase this here so we can find some other variables. What shall we do next? Let's do force of tension. The force of tension, of course, now we could use acceleration to plug it in. And that's exactly how I'd go about it. So we'll say the force of tension in this case is equal to mass of B times acceleration. Now that we have acceleration, we can plug it in. And actually, let's do that. Since we don't know acceleration, let's actually plug that in. Force of MA plus MB, right? So that's how we can find the force of tension. And let me put square brackets on this so you don't get confused. Force of tension is equal to the mass of B times the force over the mass of the system. Makes sense. Now we just need to find the force. And we can do this, right, if we have all these terms. Force is equal to mass of A times its acceleration plus the force of tension. Let's do a substitution to kind of make it like this here, kind of complicated, but using the idea of acceleration to find force. We have the mathematical relationship of the mass of the body times acceleration plus the force of tension, which we found to be MB, times force over mass A plus mass B. So the overall force is equal to all of that there. So we found all of our variables here, and this is our third idea. So we found the force, and this is just mathematical. If we had numbers, we could plug it in and find the forces respectively. So acceleration is force over the mass of the system. Force of tension is mass of B times quantity timed force over mass of system. Force is equal to mass of A times acceleration plus the force of tension term that we said. So hopefully that makes sense. We have one more problem to do. So let's do that now. Okay, so in this problem, we have some pulley system with two weights suspended on each side, the left and the right respectively. On the left, we have a 3 kilogram weight, weight A, and then we have, weight B here, weighing 5 kilograms. Let's make a free body diagram, right? We should know this by now. Draw the free body diagram for problems like this. Accelerating systems, they help a lot. So we have block A here. There's its weight, right? We know that there's a force acting down, that's its weight. That's going to be 3 times 9.81. That gives us a total force of 29.4 newtons down, and there's some force tension pulling the block up. Let's go for block B now. Block B. What's pulling up? What's pulling down? So block B is a 5 kilogram mass times gravity. So there's a force of 49.1 newtons down. But pointing up is, again, the force of tension. So this one might be a little trickier. We need to just think logically. Which block, how's the system going to move? Is it going to go where block A is accelerating up and block B down, or the other way around? Right? Is block A going to fall or block B going to go up? Well, just look at the mass. Who has a greater mass? Block B. So if it's heavier on that side, it's probably going to have more, it has a greater force here. Granted, that force of tension is equal. We know that block B is going to move down at some acceleration, and block A is going to accelerate up at some acceleration. So let's make a relationship here. The sum of the forces in the y direction for block B is going to be equal to, and let's make down positive, up negative. So we're going to say 49.1 newtons minus the force of tension is equal to the mass of block B times acceleration, right? We're saying that this system here, this equation, is equal to mass B times acceleration. We can also say that the sum of the forces in the y direction for block A is equal to the force of tension minus 29.4 newtons is equal to mass of A times acceleration. Alrighty, so now let's do some algebraic manipulation of this here. Let's solve for the force of tension here. So we're just going to move the 29.4 newtons over. We get mass of A times the system acceleration plus the 29.4 newtons is equal to the force of tension. So we have this relationship for tension, right? We don't know the acceleration. That's what we want to find here quick. So let's plug this in right here. So we're going to get 49.1 newtons minus, and that's the quantity here. Don't think it's just minus this and not minus that. It's minus both. 29.4 newtons. Drop the parentheses. So it's 49.1 newtons minus the mass times acceleration of the system minus 29.4 newtons is going to be equal to the mass of A times acceleration. Or sorry, mass of B times acceleration. I keep doing that with the masses. What am I doing? It's like I don't know what I'm talking about. Okay, so let's do some solving here. 49.1 minus 29.4, that's going to give us 19.7 newtons is equal to, and we're going to bring the mass A times system acceleration over. That's mass of A acceleration plus mass of B acceleration is equal to that Newton force. Let's factor out, right, quite fitting, 19.7 newtons, and let's divide it out. Same exact damn concept that we've been learning all this time, right? So divided by the mass of the system, which 5 plus 3 is 8. So we get an acceleration of 2.46 meters per second. That's the acceleration of the system. Okay, now we can use that to find tension. So I'm going to erase this here. We know that acceleration, we found 2.46 meters a second. So let me go ahead and erase this here. Force of tension is equal to mass times acceleration of A plus 29.4 newtons. So let's actually just plug and chug here. We know mass of A to be 3 kilograms times acceleration, 2.46. Alrighty, that gives us a force of 7.38 newtons plus the 29.4 newtons. Force of tension here is going to equal 7.38 plus 29.4. The question did give us 3 sig figs. It's 5.00 on the question bank that I'm pulling from. I did only give you 1 here. I apologize, but let's keep 3 just in theory, right? Force of tension is 36.8. Let me just check the key. And yep, that is the answer there. So that's 3 awesome pulley problems. I hope you learned the concept of solving accelerating systems. It's a lot of algebra. You got to manipulate things. And then when you add in on angles, right, that can get kind of tricky. But just remember, define the sum of the forces. Use Newton's second law. It's going to help you greatly to solve these problems. I hope you enjoyed. I hope you learned something. I hope you have a wonderful day. Take care, everyone.